Introduction to Cable Propelled Transit. Since the cars became affordable and used more commonly in the middle of the 1900s, people started dreaming of flying cars. This would especially be more true when they are stuck in traffic. This is a typical traffic jam in Manila in the 60s. Sometimes they would wish, "I wish our car could fly." Decades later, nothing has changed in the wishes of weary commuters stuck in traffic. This is Manila today. Over the years, only the car model being imagined has changed. As of today, the flying car that can travel the road and fly at the same time has not yet been invented. Fortunately, something better has already been invented since 2004. It is called an ART. It can accommodate 8 to 35 passengers per cabin. It can travel at speeds of up to 35 kilometers per hour, and you can ride on it for only 20 to 25 pesos. ART is a type of Cable Propelled Transit or CPT. In this introductory video, we will introduce CPT as one of the modes of public transport. CPT is a means of transport using a vehicle for passengers that is propelled by a cable and powered by an electric motor. This chart illustrates the many types of cable cars. In this chart alone, there are so many seemingly unrelated words used to describe a type of CPT that are so hard to remember. Adding to the confusion are more names to names in the chart. Moreover, some types of CPTs look the same. For this video series, we are going to group the 10 types into 2 groups. Namely, the major types of CPTs are composed of 4 types, marked in red boxes. The minor types of CPTs are composed of 6 types, marked in green boxes. An important type missed out in previous chart, namely pulse gondola, has been added. The major types are those that are common or major installations, while the minor ones are mostly less common or are minor installations. This is the website of Doppelmayr, the largest manufacturer of CPTs in the world. If you look at its product line, you will see that all types of CPTs are covered. We simplified the previous chart and cover only the 4 major types of CPTs for this chapter. The 6 minor types of CPTs are covered in the next chapter. Cable Propelled Transit is subdivided into 2 types, namely Aerial Ropeway Transit or ART and Ground Ropeway Transit or GRT. GRT is used as a new term in this video series to make explanation of the complex and numerous types of CPTs easier to understand. ART flies in the air. GRT runs on ground-based tracks. Using this definition, GRT can be like an LRT because its tracks are supported by closely spaced columns based on the ground, whereas the cables in the ART flies in the air. ART is further subdivided into aerial cable car and aerial tram, while GRT is further subdivided into cable liner and funicular. The aerial cable car is further subdivided into 2 types, the monocable and the tri-cable. The monocable aerial cable cars have only 1 cable to support and pull the cabin. The bigger tri-cable aerial cable cars have 3 cables to support and pull the cabin. The classification of ART into cable car and aerial tram is like the classification of shoes into leather and rubber shoes. The further classification of aerial cable car with 1 cable or 3 cables is like the further classification of leather shoes with 1 strap or 2 straps. In explaining CPTs well, we sometimes need to further simplify. We simplify by calling different types of shoes just shoes. We can also call different types of aerial cable cars just ART or cable car. From the 10 types of cable-propelled transit systems, we can simplify them to just 2 categories to better explain CPT in some video presentations. Any transport mode that flies in the air by means of a cable is ART or cable car. Any transport mode that runs on the ground and looks like a train is either a cable liner or a funicular. Hundreds or thousands of years ago, the only available material to do the transport of people or cargo was through a rope made of dried plant fibers. It can also be made from dried skin, intestines, and ligaments of animals. Over the last 200 years since the steel rope or cable was invented, it has evolved to be among the most important material in the development of CPT. To better appreciate the development of this technology, we look at its history. This is a photo on the use of cable for personal transport at around 250 BC. In the photo on the left, the strap has improved, making it easier to move. In the photo on the right, there appears to be pulleys to make the movement even easier. In these photos, pulleys and ropes are continually used in combination to move cargo or passengers. This is a sketch of an aerial tram that crosses a river dating back to 1615. The cabin is propelled manually by a man pulling a cable that loops around the pulleys. This is a large-scale CPT system. This system was used to carry materials to build a fortress. For hundreds of years, there were not much improvements in the use of cable for transportation because the ropes were not good enough. Fiber ropes have low strength and easily break under repeated use. 1834 was a milestone in the advancement of human civilization. It was the year the steel rope was invented by Wilhelm Albert. It had many important applications, one of which was in the transportation of people and materials. These are some of the early applications of Cable Propelled Transportation, or CPT. The first type to be installed was in the funicular in 1862. 11 years later, the first cable liner was installed in San Francisco, USA in 1873. Both CPTs were supported and propelled from the bottom. 36 years later, from the first CPT, both the aerial tram and the cable car were installed in 1908. Both CPTs were propelled or pulled from the top. Over the last 100 years, from 1900 to 2000, the three types of CPTs were only applied for tourism purposes. These are aerial cable car, aerial tram, cable liner, and funicular. In the case of the San Francisco cable liner, from 1873 to 1947, it was used for mass transportation. When it was scheduled to be demolished in 1947 because it was no longer efficient, people protested and won. It has been preserved until today for tourism purposes. Over the next 23 years since 1999, there have been numerous applications of CPTs in urban areas. We start with Medellin, Colombia aerial cable car in 2004 up to the latest installation in Mexico. Next, we have the Durango, Mexico aerial tram in 2010 up to the latest installation in Ha Long, Vietnam. Next, we have the Las Vegas cable liner in 1999 up to the latest installation in Moscow Airport, Russia. And finally, we have the Istanbul, Turkey funicular in 2006 up to the present installation in Seyrantepe, Turkey. Each of these four types of CPTs will have its own chapter video, wherein each will have its own history after the invention of the steel cable in the respective video chapters. These are the types of mass transportation systems. Let us look at how CPTs relate to other modes of transportation. Subway or MRT is mostly below the ground. BRT and tram are on the ground. LRT and monorail are above the ground. ART is way above the ground. As can be seen here, there are 4 levels in which modes of transport can be placed. It is only CPTs that can be placed in 4 levels. In this CPT video series, only these 4 types of CPTs will be elaborated in detail, being the most likely to be installed in the Philippines. Each of these 4 types will have its own chapter video. First, we focus on ART. This slide shows the 2 common types of ART. First is the aerial cable car. It is subdivided into 2 subtypes, namely monocable type and tri-cable type. In a monocable type, there is only one cable that supports the cabin. The same cable pulls the cabin towards the station. In a tri-cable type, there are 3 cables. These 2 cables support the cabin. The middle cable pulls the cabin towards the station. The second type of ART is the aerial tram. It has 3 cables like the tri-cable type. Similarly, the middle cable pulls the cabin towards the station. This slide graphically compares the cable car and aerial tram. A cable car can have multiple stations, while aerial tram can only have 2 stations. From an apple-to-apple comparison, we consider only 2 stations of the cable car with also 2 stations of the aerial tram. Although a monocable ART cabin has a maximum capacity of only 12 passengers as compared to the 230 passengers of the aerial tram, the cable car can transport more passengers per hour. This is because in between cable car stations, around 50 cabins stream along the line in opposing directions. This compares only to 2 cabins in between aerial tram stations. In most cases, the cable car will have a higher system capacity of 4,000 to 6,000 passengers per hour per direction. This compares to only about 2,000 passengers per hour per direction of an aerial tram. Next, we focus on GRT. We have earlier shown this slide to show the capability of MRT to go on the ground, above the ground, and below the ground. Funiculars and cable liners have the same capabilities. LRT and MRT are almost the same as to the many characteristics of a rail-based mass transportation system. They differ mainly only in speed and capacity. An example of an MRT is in San Francisco, USA, while an example of an LRT is in Manila. LRT, which is low capacity, cannot be applied underground. Tunneling is very expensive. To justify the cost of going underground, the capacity must be high. This can only be met by an MRT. What MRT can do, GRT can also do. An example of a GRT on the ground is the cable liner in San Francisco. Most of the rail-based application of CPTs or cable liners are above the ground. In some cases, it can be below the ground. These are the characteristics and maximum capabilities of the cable liner and funicular. As to cost, assuming the same passenger capacity, a cable liner will cost more. It has more complex mechanisms as it is detachable and travel along multiple stations. As to ridership, it will generally have more since it can have 5 stations for passengers to choose from compared to usually only 2 stations for the funicular. As to location of the track, all cable liners except San Francisco are above or below the ground, whereas funiculars can be above, on, or below the ground. This page graphically compares the cable liner and a funicular. A cable liner can have multiple stations, while a funicular usually can have only 2 stations. For an apple-to-apple comparison, we will consider only 2 stations of the cable liner with also 2 stations of the funicular. Both will have similar performance and capacity specs. In reality, cable liners have mostly at least 3 stations. As the number of stations are increased, the capacity of the train set may have to be reduced to maintain a required speed by a customer. Steel cables can only pull so much load in relation to speed. Despite these reductions, cable liners will always have a higher daily ridership. This is because by servicing 3 to 5 stations, more passengers will be able to ride the line. Some will ride only between 2 stations. Others will ride between 3 to 4 stations in a line to arrive at their respective destinations. There being more options, there will be more riders in a cable liner, generating more income for the owner. These are actual specs of the funicular in Istanbul, Turkey, and cable liner in Caracas, Venezuela. A funicular usually have only 2 stations and 2 train sets. These 2 stations travel in a back and forth motion. A cable liner has more than 2 stations and more than 2 train sets. These stations are propelled by a cable that moves around a loop. A cable liner has generally a higher daily ridership because it has more stations that passengers can board and deboard. It is important to know the detachability characteristics of CPTs because it will help in choosing the right CPT to be applied to a mass transportation need. The cabins or trains of the 4 CPTs are all connected to a cable that will be propelled by the power of an electric motor. The cabin or train will be connected in 2 configurations. The first configuration will be that of a cable car cabin that can clamp or unclamp to its propulsion cable. A similar configuration will be that of a cable liner train that can clamp or unclamp to its propulsion cable. Aerial cable car and cable liner are called detachable CPTs. The second configuration will be that of an aerial tram cabin that is clamped permanently to its propulsion cable. A similar configuration will be that of a funicular train that is clamped permanently to its propulsion cable. Aerial tram and funicular are called non-detachable CPTs. Let us look at the details of non-detachable and what they can do. This is the gripping device of an aerial tram, while this is the gripping device of a funicular. Non-detachable CPTs can carry only 2 cabins as in the case of an aerial tram, or similarly, 2 train sets as in the case of a funicular. They can have only 2 stations as in the case of an aerial tram, or similarly, 2 stations in the case of a funicular. Let us look at the details of the detachable and what they can do. This is the gripping device of an aerial cable car, while this is the gripping device of a cable liner. Detachable CPTs can carry several cabins as in the case of an aerial cable car, or similarly several trains as in the case of a cable liner. They can have multiple stations as in the case of an aerial cable car, or similarly multiple stations as in the case of a cable liner. In summary, we show all the 4 types of CPTs on one slide and categorize them. On the left side are the 2 types of ARTs, aerial cable car and aerial tram. On the right side are the 2 types of GRTs, cable liner and funicular. The aerial cable car and the aerial tram are the aerial cousins as they fly in the air. The cable liner and the funicular are the ground cousins as they travel on the ground. The aerial cable car and the cable liner are the detachable cousins. They can have multiple cabins or trains. They can also have multiple stations. The aerial tram and the funicular are the non-detachable cousins. They can only have 2 cabins or trains. They can also usually have only 2 stations.